Okay, well, I want to continue on with AI kind of things, and I'm going to talk about a system called Waypoints. Let me get a share screen going here. So with a share screen, with the Waypoints, let me just show you an example here. Here's a whole bunch of cars driving around a track. Mute the audio. These cars make a lot of noise. Excuse the frame rate here. It's really slow when Zoom is running. But the point is here we've got this gaggle of cars, and they're following a waypoint circuit around this racetrack, and that was very disappointing, the frame rate with that. Quit that. So the idea, we want our AIs to patrol some circuit. We want them to either enemy AIs that are patrolling, or we've got these racers that we're racing against as they go around the track. And a simple way to do this is to have them traverse a series of waypoints, starting with point 0, and then moving around to point n-1 of the endpoints, and then back again to point 0, closing the circuit. So setting up a very simple controller for an AI, just a little cube, and we're going to have it move around the circuit. We'll give it a target, speed and rotation, and a character controller that we're going to move it with. In the awake function, we'll get a cache copy of the character controller. And in the update, if we have a target, we'll form a vector between our current position and where we want to go. And as long as that is not 0, we'll form a rotation with quaternary loop rotation that points along that vector. And then we'll use a slurp to rotate gradually to that direction, controlled by this rotation speed parameter. And then we'll move the controller with the character controller move, a speed times that transform forward, time delta time. So that's the motor that's going to run our character. It's going to follow a target. So we could set up a very simple waypoint script. We have an array of waypoints. We have a proximity, how close we have to get to the waypoint before we satisfy having reached that. And we have various privates for the current target, the cube motor, and the number. We're going to get our motor with a get component, set the initial target ID to be 0, and set the current target to be that waypoint target ID. The update function is just going to form a vector from our current target position to that's the waypoint, to our transform, form a magnitude of that. And as long as the distance, whenever the distance is less than that proximity distance that we'd set, we'll increment the target ID, wrapping it around to 0 if we ever reach the number of them, and reassigning our target to be that new target, and setting the motor's target to be the current target. So here's what that kind of looks like. I've got my little cube. I've got a bunch of waypoints, and it takes forever to get going here. But it's moving to the different targets. which are indicated by this yellow line. That's part of the script here, and on draw gizmos. This is going to draw gizmos in the scene view and in the game view if we have the gizmos checked. We're just going to basically draw a yellow line from point 0 to waypoints -1, and then around the loop, connecting each of the waypoints with a yellow line. The execute in edit mode that I had up here, this allows us to see this gizmo even when the game's not running. So that's this kind of simple one. Now, as it turns out, Standard Assets provides us with a way more sophisticated and powerful way of doing this using two scripts that are provided in the utility package of the Standard Assets, Waypoint Circuit and Waypoint Progress Tracker. We put the Waypoint Progress Tracker on our AI object. We make an object that we child to our AI. It can be an empty game object or a mesh object so you can see what you're following. And we assign that in the target slot of our AI's motor, cube motor, and in the target slot of the Waypoint Progress Tracker script. The Waypoint Progress Tracker script will move this object along the Waypoint Circuit path, and it'll keep track of our character's progress, as well as interaction with other characters that happen to be following the same circuit. So we set up the circuit. We collect all our waypoints as children of an empty game object, call it waypoints. We labeled them in some kind of sequential order, say starting with one that ends in 000, then 001, etc. What it does is when we assign the waypoints, it does it in alphabetical order. So if you use numbers, that'll order them in a particular way. We add the Waypoint Circuit script to that waypoint object, and we click the Assign Using All Child Objects button, and the array should populate automatically with all the waypoints that are the children. Let me show you that here. This is, here's our waypoint object. It has children, all these waypoints, and when I clicked that Assign Using All Child Objects, it populated them in that order, making that loop around, which also has a yellow line that, that we can see these things. You can move these around and reorder them and auto rename and all kinds of other things, but basically we want our waypoints to be in some numerical order around the list. So having done that, then you go back to your AI object and insert the waypoint object. That's the one that has all your waypoints and the circuit script in it, in the circuit slot of the Waypoint Progress Tracker. So here's my character cube. Here's my, God, the lag is terrible. Here's my waypoint. Here's my, where's the motor? Here's my motor that has the waypoint target that is the child of this object, the child of this object. And I've inserted that in the motor. That's the thing the motor is going to follow. And I've also inserted it here in the target of the Waypoint Progress Tracker, which also has the circuit, the Waypoint Circuit, inserted in the circuit. There's some other things that you can fiddle with for the that affect how it works, but basically we're going to progress along the path at the speed set by our cube motor and the rotation speed. This doesn't look a whole lot different than the simple one, except that it has a lot of fancier tools that allow you to smooth the route. You can either go line by line, straight line between them, or you can follow this spline curve that it makes between all the different points. The gizmos are on here, and you can see the thing that we're tracking is that line in front of us, and our progress is shown by the little sphere there that shows where we are on the path. It's all very cool. This is how the car AI and the plane AI, both of which are in standard assets, how they work. They're set up to do this kind of motion, so both of those easily work with this kind of setup. You can also do a mechanism character, have a mechanism character like our teddy bear traverse the Waypoint Circuit. We can use the standard follow script that we developed for our AI. All we have to do is put a target in as a child and set that as the target of our AI and include that in the Waypoint progress tracker. And then we can get things like this. Oh, here's a car. This is the standard AI car that's going to follow the path eventually. So the car will follow the path. And the AI airplane will also follow such a path, although of course you'd want it to be up in the air someplace. And here are just some teddy bears that are set up to follow it. I didn't mention the priority on the Waypoint progress tracker. You can set a priority, and that priority affects who has the right of way. I believe the lower number priority have the right of way. They'll have more opportunity to follow the path, whereas numbers with higher priority, that doesn't make sense, but that's the way it is, will yield to them and get out of their way. So all of that's very, very cool. And that's the Waypoint navigation, something that we can do with our AIs. So I'm going to end the share screen here and stop the recording, and I'll see you all in class. Bye.